Okay, just a little bit more experimenting with this. These were the coils I had on there, and this is mainly for John and anyone else that wishes to replicate it. It's trying to work out whether it will work with different types of coils, different configurations, or it has to be this type of coil with this type of resistance. Works fine with two of those hooked in series, or one of them, as it does over on our original version. So those coils work alright. There's the drive coils, and I'm using one, of course, that is hooked to the base emitter junction. I tried a larger air core out of a transformer. This one is 72 ohms. I can't get the machine to run with it, so no good. This one here is a little bit smaller. It's 96, 97 ohms. Very hard to start, but it did eventually get it to work. However, our input and load numbers were terrible. Each one of these is about 170 ohms each, so we've got about 340 ohms of resistance for those two hooked in series. The coil I'm using at the moment is the secondary out of a microwave oven transformer, 138 ohms, and that works just fine and dandy. So it seems anything over 100 ohms of any configuration, whether it's wrapped around a former in square or it's no former and in a rectangular shape, all seem to work okay as long as it's 100 ohms or over, and this is relative to the circuit I'm using. Next we tried a 12 volt battery, about 12.47 volts, and no good. It did work, however our input compared to our output wasn't as good as it is now. We only got half as much again on the output as what we were putting into the system. So it would seem that the way I have it set up here and the configuration I've given you, John, that 9 volts seems to be working very well with the circuit. I have a little sniffer coil here which is hooked up to the scope. I have got it polarity correct, so when the pulse or the current is sent to the coil, that is reflected to indicate the positive going through the probe. This is what our scope is telling us from our sniffer coil. Now, although you don't need this coil anywhere near the drive coil for the circuit to run, if you have it around the right way, you can in fact actually increase the current a little bit by moving it closer. Too close and everything shuts down, the circuit stops. Too far away, it doesn't matter, it just runs as if the coil wasn't there at all. If you have this coil around the wrong way, you will see the circuit starts to die. By moving this coil closer to, so we're getting closer there, and when you see it going noisy like that, it means this circuit is nearly going to stop right there. Now all that mess there I can actually see, you probably can't on the camera, but I can see that the LED is very randomly jumping up and down in brightness, and very quick flashes. And I've also found to tune it the best, where we get our best input to output ratio, is to have the bulk of it below our 0 volt line. When we start to lift all the spikes up above 0 volts, we consume more current and we don't gain the same effect. So right about there is pretty good. These two extra yellow wires you can see here twitched together are now hooked in series with the LED and our storage caps. This is so I can turn the LED off and watch what our meters say. So in theory these two meters here should indicate a total what output into the system, less than what these 2 meters here are telling us the battery is putting into the system. But before I go and do that, we will let you get these numbers. We're going to need these numbers to throw around in some calculations. And please remember we are dealing in DC current, no pulses. These meters are reading DC current. Or DC power, as Chet would like me to say. And okay, this is from our storage caps to our drive caps. Now you will see that I've posted the schematic before this video on the thread, so now you will all know what's happening and where the meters are placed. Okay, so now we're going to disconnect our LED. Sometimes it shuts off, sometimes I have to restart it, sometimes I don't. So we'll see what happens. Okay, it's still running because the voltage on our sniffer coil is now shot through the roof, as it would. And that's what we get from our sniffer coil with the LED disconnected. Very nice ringing. Okay, as you can see, our input current is soaring, along with the current from our storage caps to our drive caps. Now what this is going to do is this is going to show us what the what current was coming back out of our LED and being put back into our caps. And this will give us the efficiency of the system with and without the circuit loop back into the collector caps, storage caps. Of course the current or the power that's going through the LED is pulsed, very high frequency pulse. Right, the meters are settled down, so our input from our battery now is 8.93 volts at 904 microamps. The current that is flowing from our storage caps into our drive caps, which is driving the whole system, is 8.6263 volts at 901 microamps. So 8.63, 901, 8.94, 904. So you can clearly see by those numbers that we have a loss, as we should, because we have resistors here and we have caps here and we have caps being charged by caps through resistors, and of course inductors are a loss. Our transistor is a loss. And remember, we're only dealing in very small amounts of current here, so those losses are going to be definitely recognised by the system with the amount of input we are giving it. So that's pretty much it. Now, disconnecting the wires is pretty easy one-handed, but joining them back up is not. And I'm not going to be able to twitch them, so I'm going to have to hold them. As you can see, we're running again. Can't see nothing on the scope because I had the voltage divisions up at 5 volts per division. The reason things take so long to settle back down when we start adjusting and playing is it's a very small amount of current flowing through resistors and caps, so it's going to take time for the large capacitance to adjust and settle in. So the next thing to do is hook these two wires up to a switch. Relatively stable now. So once again, that is our input from our battery, and that is the power being delivered from our storage caps, which are those three there. Go through our meters, through the amp meter, and to the three caps that the system is drawing from. Okay, well we'll keep on looking into it and see what else we can come up with.